Hello everyone, I hope my voice is loud and clear and it's audible. Without taking a lot of time, I'll just jump right into the topic. I'm sure you are very excited to hear about all the different topics in this conference, and along with other speakers, I'm sure this topic will also be very informative. And in case you have any concerns and questions, just feel free to reserve them for the last part, wherein I'll answer all the questions. I'm doing it remotely, but doesn't mean that we cannot interact. Just feel free to bring all your queries or questions. Hold them back until we have later on Q&A sessions. So just let's get started. So today's topic I'm taking is how we can secure the containers and Kubernetes deployment for your next projects if you're working on any. I'll be taking and discussing few best industry practices, tools, and what are the common differences between these two terms and other referring things which we quite often see when we are talking about these two terms. So bear with me and let's get into the topic. Before we start, as customary, I'll just like who am I? I'll be saying that currently I'm working as senior manager with Cloud Risk Advisory with Deloitte. I'm based out of Singapore. I consider myself as blockchain, DeFi, and Kubernetes enthusiast, and I also do a lot of regular speaking and panelist sessions in various conferences around the globe. I love teaching and building community, and that's one of the reason I'm participating in the conferences as well. To summarize, I'll say that I'm engineer by qualification, a consultant by profession, a hacker at heart, and a researcher by passion. I have been in the industry for quite a while now, and I have seen a lot of new technologies. I started with a lot of new technologies and have been working in many. So I'm quite excited in with this whole cybersecurity domain itself. New engineers coming inside, researchers coming in the technology. So I'm looking forward to contribute and make sure that this new domain of containers and Kubernetes is something which is touched upon and is not something which is very new to everyone. So I'll be sharing my thoughts on that. In case you want to reach out to me after my talk or any other questions you may have which is not clear during the session, you can reach out to my socials. I have shared my Twitter, LinkedIn, which you can reach out to reach to Nikhil. For all the Gen Zs, if you are not on Twitter or LinkedIn, I also have shared my Instagram. You can reach out me there as well. So let's get into the agenda next. So in this session, I'll be talking about the containers and the virtual machines. What are the basic differences? What we had talked about, is this is really containers something which will overtake the virtual machines, or what are the benefits? So I'll touch on those topics. I'll also talk about the benefits of containers over the virtual machines. Then we'll talk about Kubernetes and Dockers, like what are the key differences and why we are using these terms when we talk about the containers. Later, we'll see some best practices on secure deployments of containers and Kubernetes. In the last section of this talk, I'll talk about the common tools and the players in the container security space right now, and which you should be aware of. I'm not trying to name or particularly highlight any. It's just something which I'm aware of, and you should know who are the key players. Let's go to the first part, which is virtual machines and the containers. So as you might know that containers are like kind of a form of operating system virtualization. A single container might be used to run anything from a small microservices or a software processes to a large application as well. Inside a container, there could be all the necessary executable binary codes, libraries, and configuration file which can be included. And compared to any kind of a virtual machine or like a server, virtualization approach which you normally see in a traditional environment, it makes container more lightweight and portable. So that is like one of the major reason. If you see from this architecture diagram, so if you see the basic building block here, a lot of things remains a constant. Like for example, in a virtual machine kind of environment, we have an infrastructure operating system which is being shared, and then we have the hypervisor which has its own guest operating system, and then further libraries and applications which is running on the virtual machine. In case of containers, the sharing of the layer is also at the operating system, so the host operating system layer is also being shared, and then there is a container daemon which runs, wherein all different kind of applications and libraries can run on that particular container daemon. So in that case, it makes it breaks the particular host operating system layer from the overall architecture, that saves a lot of space and overhead from a container. And that's why they are called more lightweight, and like the reason why they are more portable. So that's one of the reasons from a architecture, basic architecture wise, which makes containers more handy or portable. I'll be taking more details, what are the key differences between virtual machines and the container in the next slides. So, as we see, like a basic container jokes, yeah. So containers are just lightweight VMs, right? Yes, definitely. But that's not the only thing. There are other reasons why we prefer containers over the virtual machines. And what are they? Let's see them. So I'll say that like these are few criteria which have been identified, and we are comparing virtual machines and Docker images or containers in this case under these areas. So first, from a OS support perspective, virtual machine, as we have seen from a previous architecture, it takes a lot of space, wherein Dockers contains less space. From a boot up perspective, like virtual machines takes a lot of time because of the operating system it has, wherein Dockers are very fast from a boot perspective. From a performance perspective, again, because of the excessive size of the virtual machine, it makes them like unstable from a performance perspective compared to Docker. Scaling, virtual machine is definitely difficult to scale up because every time you need to consider a host OS layer, wherein in Docker it's very easy to scale up. And efficiency wise as well, like Docker being very easily scalable and portable makes it more efficient. Portability is something which we have seen from architecture, that like virtual machines are less and have a lot of issues when we talk about the portability, like from a dependency perspective, wherein the Docker main feature of the Docker is that it is a bit portable. Space allocation wise, virtual machine, like the data volumes cannot be shared because everybody have their own operating systems and have OS data volumes, wherein Docker being like sharing the same operating system, they can easily share the same data volumes. So this is like a common, I'll say, differences. Sometimes people also confuses container technologies with virtual machines or server virtualization technology, but there are not much differences. There are like it is completely different from the VMs, I'll say. Virtual machines on one case run on hypervisor environment, where each virtual machine should include its own operating system, as we have seen from the architecture, and it should have its own binaries, libraries, and application file, of course. This will, what it will do is it will consume a lot of memory space, as we have seen from here, wherein like in case of containerization, they share the same operating system or the kernels also sometimes, which is very light in size. And like, just from an example perspective, it could be in just a megabytes. And this means like the containers are very lightweight and can be used anywhere, and it takes just a couple of seconds to start them. So versus like the gigabytes of the virtual machines, we just have like kind of megabytes of container images, which can make our job easier. So that's one of the reason why containers are getting more popular right now, and a lot of industries are like going towards the containers as we move towards the cloud. Okay, going to the next topic, which is like talking about what are the benefits of the containers. I have a lot, but let me start with first. Like in simple words, containers like makes building, deploying, and scaling cloud native application easier than ever. Like that's the best and the simplest I can put it on. Uh, what does it mean is like for any cloud native developers, like the biggest benefits of containers, if I have to say, could be that it like developers try to avoid as much as much friction as possible when they are moving their code from like testing from a dev environment to a production environment. As like when they package their application, they they like it always comes with an error. Like there's, you might have heard about the typical problems that it runs on my system but not the other production system. So those kind of issues can actually be solved easily, wherein a developer can actually package their application code as a container and then can push that container image anywhere, be it production, deployment, anywhere environment, and it will definitely run because now you are packaging it in a container images. So that's one of the major benefit, that it eliminates that friction and that issue of running it on my system. From next perspective, I'll say that all the dependencies associated with application that are included within the container. So this enables application to run very easily and identically across the virtual machine. So you don't have to focus on individual applications and their dependencies. It will remove that barrier of dependencies, and will make sure that your application is running over the virtual machine, bare metal servers or wherever. And doesn't mean only on the on-premises environment, but even on the virtual clouds or the public clouds environment as well. So it makes sure that your application becomes a single source of truth for all the developers. So that's another benefit. I'll also say containers take faster build time. So like comparative to any VMs or anything, the flexibility and the portability of containers enables developers to make huge gains on productivity, and that was like previously very difficult to achieve when we were talking about the virtual machines and working in a virtual environment. Another benefit I'll say container has is the confidence which developers get when they are deploying their application, because they know that this application, whichever platform they are running is, will be working, because it is irrespective of an operating system layer. So that's another thing which is very important when we talk about the containers. It removes that particular mindset between, or that fear within the developers. They feel more confident when writing new code or deploying, building new application. Another thing I'll say the benefit would be that from a collaboration perspective, like multiple teams can use the containers and they can work on the individual parts of the application without disrupting the code. So because of the container based, and the reason why this container is getting popular is because the application is not just now a single stack, it's working on different containers, multiple container clusters will be running. So if you want to redeploy, if you want to make any changes within a code or in a particular service, you don't need to change the overall application. You may just need to work on individual sections of that particular cluster, container cluster, and you can collaborate with different teams, make sure that it is working, not interrupting the overall function of the application. So that's another important thing which I think is a very important part of containers and what makes them important. A typical question would be, in short, if I have to summarize anything of this, why containers and why they are important, I'll say that it runs on any operating system, be it Linux, Windows, or anywhere. It runs anywhere, like on premises or cloud. You choose where you want to run it, it will. Any type of application architecture. So if you are running in a traditional monolith applications, definitely it will work. And if you are working on a more modern application architecture, like any microservices based architecture, containers are the best fit for these kind of architectures, and it makes your life easier. From a language perspective, it supports any languages. So that's another reason that why people prefer using containers when they are talking about the new modern app deployments, app developments. So these all makes containers very special. In any new IT architecture, cloud native application still needs to be secure, and container environments, I feel, will bring them a range of cybersecurity challenges involving like images, container, host, all these kind of things which we had just talked about. This all things definitely helps, but it also will become some cybersecurity challenges as well. So we have to talk about those cybersecurity challenges now. So in the next few slides, I'll talk about the cybersecurity challenges and what kind of things people are using this for. Before I move towards the next topic, which is like the Kubernetes and the Docker, as you have seen from my slide, I just want to talk about the few use cases of the containers, like what currently organizations are using it. So I think like the first major use cases is the lift and shift. So basically, right now, a lot of organizations are using containers to migrate their existing application into the modern environment. That is one of the classic example of lift and shift. Then I think the refactoring of existing applications, like a lot of time, if lift and shift is not possible, but some part of the application can be refactored in a modern application. That is another area where our organizations are considering the shift to containers. For the new applications, I'm 100% sure a lot of applications are completely 100% going towards a new container based native application. So for any new application projects, if you are developing a new application right from the scratch, I what I see around in the industry is that they are going with the container native application. That is the future, definitely. um, for like a lot of time, for from an environment perspective, from a customer perspective, in order to improve their customer experiences and like the support of other services, like for a microservices based architecture, that time also like distributed application and microservices are used, which can actually isolate the deployment, and whenever required it can scale up the individual container while building an application. So that is another area which is being used where the containers are very popular. From other perspective, I see that like during the DevOps support, like when we are talking about the CI/CD pipelines, and during the DevOps, container technology is like something which is very promising, as it is streamlining the overall build, test, and deployment from the same container images. So you don't have to rescan everything again and again. You can like certify, make the architecture immutable, make your container images immutable. So that is another benefit wherein like another use case I'll say organizations are using right now. Also, apart from all these things, deployments and the faster deployments and the cloud native architecture, I think containers are also used a lot of time to deploy and support like similar processes from a background perspective, like kind of ETL functions or batch jobs. For those kind of things also, a lot of organizations are using containers now. So from a usage perspective, from I'll say from their functioning perspective, containers definitely are very good tools for the future, for the technology. But as I said earlier, like all these new challenges, as much as interesting these container environment seems, they will definitely bring new cybersecurity challenges from images and containers, host, runtime, these all orchestrations perspective. So we need to be protected against all these new technologies, and that's what we'll be discussing in the few next upcoming slides. So the next interesting topic is the Docker and the Kubernetes and how they do relate to the container. So we talk about these containers, and whenever we talk about the containers, I think two terms which are completely indifferentiable is the Docker and the Kubernetes. So today we'll discuss what are the differences between the Kubernetes and Docker, and how do we plan to use them in their like from a container perspective. So if you are like already using the container environment and you are familiar with, you would have talked about these you would have heard about these two popular tools which are we use to build and manage these containers, these like the Docker and the Kubernetes, of course. Docker is very popular runtime environment which is used to create, build software containers. It also uses Docker images, like kind of like your container images, to deploy containerized application. And it can or like any software in various environment, you can use it from development to production or the testing environment. Docker is completely open source, so that's one of the benefits, and it can work on any environment including Linux, Microsoft, or like from on-premises or cloud-based infrastructure. So a lot of positives when we talk about the Docker. From when we talk about the containerized application, it can definitely get complicated when we increase when we talk about the scalability or the increase in number of containers, and specifically in the production environment where many might require 100 or 1,000 of separate containers. So it is during that time, during like the major runtime, container runtime, uh, Docker will definitely benefit, and they will use tools to orchestrate and manage all these individual containers which are running in the operations. So that's the time wherein this Docker and the Kubernetes are actually coming into the picture. These orchestrate your run container operations. Kubernetes is also something which is like orchestrate the operations of multiple containers, and it works in harmony along with the containers. It manages areas like using underlying infrastructure resources for containerized application, such as amount of compute, network, or storage resources. So these are like few areas which they works on. They also have like orchestrations, like this orchestration of Kubernetes and Docker Swarm in this case. The major benefit of these are that it makes it easier to automate and scale the container based workload, so that during your live production environment it can satisfy or it can work based on the kind of environment we are having, or the requirement application is having. So that is one of the major use of Kubernetes and Docker. From a difference perspective, as we are talking about the differences between the Kubernetes and Docker. So Docker is like a kind of platform, but when we talk about the orchestration platform, Docker has its own Docker Swarm, wherein Kubernetes is an individual orchestration platform. From now, we'll compare Docker Swarm versus Kubernetes under the five major areas. The first one definitely is from a scaling perspective. When we talk about like how orchestration is important, the major reason why like Kubernetes being very popular out of Docker Swarm or any other orchestration like OpenShift, and there are a few other uh, container orchestration platforms available in the market. But out of them, I'll say that the most popular one is the Kubernetes, and one of the reason is because Kubernetes supports auto scaling compared to others. So that's one of the reason why a lot of developers or organization, when they move towards containers and the orchestrations, they tends towards the Kubernetes. From a community perspective, I say honestly both have quite good community. However, Kubernetes, because of being more widely popular, have a more active community. From a clustering perspective, like Docker Swarm, it's pretty easy to start a cluster. It has its own advantage, wherein Kubernetes is a bit complicated process, wherein you need to identify the correct way which you want to operate, like from kubectl or maybe your etcd. Different ways are there. So it's a bit difficult when it comes to Kubernetes, but still it has its own advantages. From a API capabilities perspective, like Docker Swarm, because it's a Docker owned products, it is limited to only supporting the Docker APIs, wherein the Kubernetes is the reason is that it is not the agnostic to Docker. It can overcome your constraints of Docker and Docker APIs as well. So that's another reason why it is being widely used. um, I'll say from a production deployment perspective, like a lot of applications are not much deployed on Docker Swarm. When we talk about the Kubernetes, Kubernetes is like deployed at various scale amongst organization, and it is very popular, as I say. So it is like definitely one of the preferred choices. A lot of organizations are actually using it from a orchestration or managed services perspective as well, when we talk about the cloud native. So like in the next slide, I have tried to compare the what are the current applications or not the application, but uh, current utilization of Kubernetes and over the cloud deployment. So when we talk about AWS, GCP, and Azure, these are all like they all have their own managed services when we talk about the Kubernetes. So like AWS has EKS, GCP has GKE, and Azure has AKS. And if you see, like they a lot of clients are preferring the managed Kubernetes service, and across any platform you just see. And that's one of the reason why I say that when we talk about the cloud native deployments, these all technologies are very useful. Only challenge for us is that the more promising they seem, the more we have to be concerned about the security. We need to know what are the cybersecurity challenges for these kind of deployments, because these are very new. We should not just deploy and then think about it. It should not be an afterthought. We should think about the security when we are trying to deploy it, and we should follow the best practices. So in the next section of the slides, now we'll be focusing on the best practices when we talk about the deployments of the deploying the securing containers and the Kubernetes. So here we are ready with our lightsabers. Let's go and secure these container deployments in the next ones. So when we talk about the container security, I think the major part I'll highlight is that there are six major areas where the different challenges are there. And Different paths are there when we talk about the container security, when the different challenges. First one I'll say is the open source supply chain risk after these recent attacks. When we talk about the supply chain attacks are getting more popular between the bad actors. So this another very important is when we talk about the container security. Image and compliance risk, host operating system risk, risk in the registry where we have all the system images stored, then the runtime or the network related risk, and then the last would be the orchestration related risk, like the platforms we are using. We just talked about the Docker Swarm and the Kubernetes. So these platforms which we are using during our deployment, these have their own form of risk. So the from a challenges perspective or the risk perspective, there are many containers. We cannot just look at the positive side of the container, we also have to see the untouched side from a security perspective, and these all risks are important, like what kind of different things would be there and what we have to secure. And containers, like specifically the users who are using the containers, need to ensure that they have a purpose built full stack security to address like this vulnerability management, compliance, runtime protection, and network security requirement of their application. If they are not focusing on those areas, it will make their life very very difficult. So these are like the six areas which I feel are challenges from a security perspective. In the next slide I'll talk about what should we do from a best practices, so not just like identifying the challenges, but from a security perspective, what should be our next steps, what we need to do. So let's see one by one, to individually for everyone. So talking about the image and the compliance risk, I'll say that when we talk about the Docker or container images, we need to ensure that we have a vulnerability management tools present which scans the new images added to your registry, or whenever a developer is trying to use any new images like Docker image or any container images, they should be scanned using a vulnerability management solution. And if possible, you should integrate these tools to your DevOps pipeline. If you have a DevOps pipeline, make sure that you have these tools integrated with your pipeline, so that these new technologies, yeah, whenever you're building any new pipeline or any new application, you can use already whitelisted images from a previous scan, make those images immutable, as we say, from our architecture's perspective, so that that risk is minimized. I'll also suggest that you should also implement some quality gates when we talk about the vulnerabilities from each stage perspective. So not like just from a deployment stage, but right from like the build, test, and deploy stages, different stages of your DevOps pipeline. You should have some quality gates, some checks which should ensure that your deployment or your images does not have any particular risk from a compliance perspective. Second, I'll say from a registry perspective, since containers are made of libraries, binaries, and application code, it is critical for all the enterprises to establish like an official container registry in their organization. And it will be like the first step of building the security, I'll say, and it will be a first step to their DevSecOps pipeline or DevSecOps journey, because then they'll have the overall visibility of what images are being used. They are not just like pulling the images runtime from the internet, which will bring in the risk of, let's say, open source or the like supply chain attacks from a completely unknown images. And that's so a container registry, what it does is it provides a convenient, a centralized meaning of storing, distributing application images. A lot of application right now like can have like tens or thousands of images stored in their registries, because registry is like central, and it is a way in which containerized environment operate. It is very important for us to secure this registry as well. So any kind of intrusion or vulnerabilities within the registry, we should like know about it at soon as possible, and it provide us also an opportunity of compromising that particular application which is running. So what we can do, we can continuously monitor these registries for any changes in, let's say, any status of the vulnerabilities. If there are new vulnerabilities within the registry, we should know about it. So continuous monitoring or a security scan should be there on the registries whenever we are pulling, let's say, new images from anywhere. It should be make sure that we are pulling it the new images from a trusted sources, and they are security scanned. And also the I'll say that You should not just completely blindly follow this kind of practices of monitoring. I'll also suggest that you should log down the server or the host registry using some secure access policies. So having a good access policies, or having some kind of rule based access control metrics to who can access when, what kind of things they can access, that also helps when we talk about the registry and how we can reduce the risk related to the registries. Then going to the next one, which is the orchestration related, or like Kubernetes and Docker. So container orchestration is definitely a process wherein it helps to enact or like make sure that you have proper access control to prevent the risk from over privileged accounts. So a lot of time we can have some over privileged users accessing it, and that can like relate issues to the network or some kind of like lateral movements over the network. So by having proper IAM in cloud security and some least privileges model, if you are following a defense in depth kind of a model, what you can do is, like in Docker and Kubernetes both, you can explicitly whitelist and implement the security on the infrastructure teams and ensure that the users only perform command based on their appropriate roles. They don't do anything which is beyond their role. So that kind of identity and access management controls you can implement within your Docker and your Kubernetes. So that's another good part. Also, what you can do is you can also protect your pod to pod communication and limit your damages from the attackers by like removing the lateral movement through the environment. So securing any kind of front end services would be another step you can implement when we talk about the orchestration related risk. So this is another interesting risk which happens. Then from a network or a runtime perspective, like containers all most of the times is like running in the runtime, and we can identify new vulnerabilities in the containers runtime. Even if they have scanned initially in a build stage, there may be some runtime vulnerabilities which can come from a code. So those kind of runtime scanning is also important. And it is, I'll say, one of the most difficult part when it comes to container stack, because like unlike the traditional security tools, it is there is no nothing as of now that mature which is defined when we talk about the continuous monitoring. Definitely now there are a few more tools, but still, like from a completeness perspective, they are still I'll say in a trial basis. uh, I'll say some organization should also leverage runtime protection, runtime encryption of the containers. That is one of the important key aspect, because don't know where your container images may run. So using a container runtime container encryption, runtime container protections are definitely important. They will help to ensure that you are compliant, you are cyber safe. And a lot of vendors are actually working in this particular domain as well when we talk about the runtime security of containers. One I have in mind would be Fortanix. They have this runtime encryption, which is very critical when we talk about the container security. So definitely these kind of new technologies, these kind of new solutions are something which you should keep an eye on when we talk about the container deployments and how you can avoid those kind of risk. From a host OS perspective, I'll say that try to use minimalistic operating systems to reduce your attack services. Try to use kind of hard coded, or like kind of something which is already um, I'll say best compliant or limited functionality kind of operating system, not something which has everything opened up. So limited processes, limited ports open. So a hardened operating system is suggested when you should use. Also, your operating system should undergo a continuous vulnerability scans, so that anything which is detected at a kernel level or maybe operating system level, it should be flagged right from the start. The last one I'll say is the open source supply chain risk. So tools like source composition analysis, these kind of tools will be helping a lot to avoid these supply chain attacks. So recently US also has released this bill wherein it has been made mandatory to have a software bill of materials for all the applications of the software. So this will be something which will work on this area, wherein you can have this remove the supply chain risk by knowing or using these source composition analysis tools, and checking from the vendor where you are buying these tools, what is their software bill of materials, so that you are like you have your own due diligence when it comes to the risk associated with it. So I'll say these are some of the situation wherein like how you can use and make sure your next containers when you are talking about are secured. You make sure different levels of your pipeline or container deployment cycle, you can implement these different security gates to ensure that you are protected, your containerized applications are protected. But this is just one part. We also have to secure the orchestration, that is your Kubernetes. So as the Batman says, we need to see about the Kubernetes. So from a Kubernetes perspective, I'll say that from the overall build, deploy, run pipeline, there are basic things which we need to ensure. Like we have seen build, deploy, run already right now from a container perspective, that you should scan the image, you should remediate anything which you are finding. You can see, make sure that you have limited privileges running when we are trying to deploy that particular container images. And then later on, from a running, like during a runtime perspective, you should have a continuous monitoring. You don't use like default namespaces or network settings, those kind of things when you are trying to run that particular container images. But from a Kubernetes perspective, I'll say that updating the Kubernetes very frequently whenever new releases are there is very important. Making sure your API is secure, because Kubernetes is all about the API server. So securing your Kubernetes API is something which is very important, like you should know it. Like though Kubernetes has like several built-in security advantages, like container images are usually replaced, not patched or updated, which leads to better version control. It also increases a lot of opportunity for exposure. So Kubernetes, like because it is relatively new and complex technology, I'll say we don't have enough talent to fully manage and secure it right now. And that makes it highly attractive to hackers, I'll say. So whenever we are addressing Kubernetes security, it is nearly impossible to separate the Kubernetes cluster from the other layers of the cloud computing. And hence these layers, like I'll say, include not just the application but also the code itself, the container images, the Kubernetes cluster, and as well as the cloud or the networking layer which we have, which we always see when we are trying to deploy. So all these are different areas which we needs to emphasize when we are talking about securing the Kubernetes. Each layer of this like builds on the previous layer. So what makes us like whenever we are trying to achieve a defense in depth, this makes sure that we have to make sure that each of these layers we have to protect them at an individual part. So not just the code or the container image or the Kubernetes cluster, but we have to make sure that we are securing each of them at an individual layer. So this is something which we have to be focused on. Okay, so this is the next part, and in this section what I wanted to do is I want to cover the overall flow of cloud native application deployment in a new modern DevOps pipeline. So like let's say if you are using a Kubernetes based orchestration to deploy any new website on a container, what are the different security checks which you have to undergo along with the different stages of the DevOps pipeline? I want to cover in this part whole flow like that. So I divided into 3 4 stages. First, let's say like what you need to do when we talk about the Kubernetes security during your build stage. So right from a build stage perspective, I'll say you should scan your image and the source code. As any application you are, when you are implementing, like we normally do various scanning tools like SAS, DAST, IAST, SCA. You also, these all will ensure that your code is as secure as possible. I'll also say don't like you don't forget to use open source code, which is like most of your application may be using open source code. So what I'll say is like you should have something to make sure that your open source code is secure. So like a library checker or open source checker, OS open source checker, those kind of things should be important. You should implement automate your workflows to ensure that vulnerabilities are remediated as soon as possible and code is secure. Also what you can do is you can make sure that you are using the most updated image available, as it will be most secure image available. So destroy anything which is outdated or it is like really not possible to patch them. So that is something which you can do during your build stage. During your deployment, what you can do is First thing I'll say is don't deploy images from unknown sources. Don't do it if you don't know the provenance of any images, where it comes from. You, if you don't trust it, don't deploy it. Do the scanning of the images during that deployment. You might have already find the vulnerabilities since your image was last scanned in development, but make sure that you are also doing a continuous image scanning later after the development stages as well. Also use image admission controls, like if any image violates your organization security policies or prevent a container from running, it should make sure that you need higher privileges to make sure that it is running with that particular privileges. So make sure that you have some kind of a quality checks or control gates in case any vulnerabilities are found in your pipeline. So it should not go to the deployment, it should need additional value of that. I'll also suggest that you should limit the privileges which are used by containers. So don't give or don't make sure that they are running with the highest privileges. Make sure that they follow the least privileges model. That will really help in securing your deployments. And I'll say that don't use your defaults, use your defaults when we talk about the RBAC or let's say network policies. So ignore or avoid using the default configurations. It will not be a best decision you will make. So enable the role-based access control which you have in the container orchestration, and it will help you to regulate your access based on the roles which your individual users or services may have. So that will be another good best practices when we talk during the deployment phase. But what happens like after the build and the deploy, the next phase is the production, and from the production also we need to make sure that we have some security checks there. And what we can do is we can scan images in the production, as we have talked about earlier, we may have missed out some new vulnerabilities during that time, or maybe some new are of like came during after the deployment. So to make sure that we are meticulous we about the content scanning of our images, that's one of the important part. What we can also do is we can secure and inspect our network using maybe a container firewall, which will like kind of apply any network security techniques to our cloud native Kubernetes environment. So not just like relying on the traditional environment, but using some container firewall is also something very important aspect which we can work on. We can also make sure that our network traffics are like creating for network traffics is following and creating and defining the creating like the network cluster traffic basically is following or working as per the policies we have defined on the cluster. If you are if you are not able to control those network accesses in and out of the container applications, that is a red flag, yeah. So make sure that we have that network policies defined at an orchestrator level. Also, I'll say that you should establish the security boundaries using namespaces. They will allow you to divide the cluster resources between multiple users, so that is definitely go. From a security policies for the pods perspective, I'll say like pods are the smallest execution unit in Kubernetes, and that's what are used to organize your containers as well. So what you can do, you can use pod security policies to address issues such as container running as root and if they are running with over privileges. So those kind of policies can be used using the pod security policies. What we also do I suggest is that when you are replicating any pods or you are trying to scale up using existing identical behavior, try to monitor and analyze the pod so that if you see anything abnormal behavior within the normal behavior, like normal something which is going, which is not something as usual, then you can actually flag it and investigate that particular behavior so that in case of any kind of breaches you know where to look for and what to look for. So that is very important. So make sure that you analyze those pods for any kind of abnormal behavior during the deployments after the production. From a Kubernetes perspective itself, like I say that as in the previous slide I have mentioned that you should update the Kubernetes very frequently. So Kubernetes not only covers the only three reason the version. If you are not updating Kubernetes regularly, what you will miss is like on any new patches of recently disclosed vulnerabilities, you will be able to miss that. So try to make sure that every quarter you update your Kubernetes so that you don't expose your organization. I suggest quarterly is a fair enough thing. Kubernetes API is something which is very important part of this applications, this modern cloud native deployments. So make sure that you don't leave your Kubernetes API publicly exposed, and it should only allow access via an internal network or a VPN. It is very, very important. So make sure that you take care of those aspects when you are deploying your next containers in the DevOps. So this is like the major, like on a high level, I have talked about what are the various things you can do, and it applies for all the type of deployments, like not just on the AWS, Azure, GCP, but any kind of cloud you are using, be it managed services or be you are managing them yourself. But make sure that these are few things which you are taking care when you are deploying using Kubernetes, your next application. Cool. So let's go to the next one. Now we talk about the DIY part, wherein what are the some popular tools or the vendors who are working on this container based solutions when we talk about just from a security perspective. So there are many, like in the last year itself, like the container security solution that organization can rely have grown from like both capabilities and sophistications, like multifold. Like regardless of what level of DevSecOps maturity anyone has attained, any organization has attained, cloud security or like container security specifically are something which are more accessible than ever. Container security solutions, which any organization will be required to adopt. There are many solutions, like as you can see from the slide itself, there are many players out in the market right now, but what we are looking is the couple of them. So in the next slide I just talked about what are the key areas which you should talk and what are the key players. So from an area perspective, I'll say that from a container security, like container monitoring, container scanning, and container firewalls, these are the three major areas which are from very highlight from a market perspective, which every of these vendors are targeting. So like the ability to monitor your registry for vulnerabilities, like the same thing we are doing a vulnerability assessment for container monitoring for any cybersecurity or IT related things, and making sure that we timestamp any events which are occurring in the containerized environment. That's like container monitoring. From a container scanning perspective, like scanning all the libraries and the container images for any vulnerability. So doing a basic vulnerability assessment of the container images using the scans, that is like another tools which you should have, like Prisma Aqua have it. Container firewalls are something like not from like traditional firewalls, but like a container firewall is something which will inspect and protect all the traffic entering and into your existing container, as well as like moving outside from the external network or your legacy application. So most container firewall will run as a sidecar, so that they can enable that network security to like to other environments which they are running on. Apart from that, you should have like some there are other tools which what they do is they do a configuration assessment against the best compliance or configurations like CIS or NIST. So these kind of compliance scans or the policy scans are also done by a lot of tools which are very important from a compliance perspective. So tools which you see on the slides, they do support all these kind of different areas which we talked about from a container secure perspective, and these are just few which I know of. Definitely there will be many, and what you can do is you can start exploring these. Like if you have never heard about this, you can start exploring these to see which is best suited for your organization, for your application. For me, I am quite comfortable with a few of them. So just make sure that you know about these tools when we are talking about the container security or the Kubernetes security. Okay, so before I end this session, I just will want to say that Kubernetes and containers are like everywhere. With their rise in popularity, security should be a primary concern and not an afterthought. As I keep on repeating, you should not deploy the applications and then see, okay, now we should see the security. That will definitely, that hasn't worked with Tesla, they got breached. That hasn't worked with any other organization which has used Kubernetes or containers before. So make sure that you don't take that step. you learn from the failures, and make sure that you think about the security during the deployment, during the design phase itself, not after the deployment. So that would be my final food for thought before I end this session. So that's all like for this session. Thank you so much for attending this talk. I hope this is a bit informative for you. If there are some areas which you still like to know about it, I have shared my socials here. You can reach out to me. I'll be happy to help you guys. Now it's time for the Q&A. If you have any question and answer, feel free to share with me. And if you are a bit shy, or you are hearing it later after the session is over or the conference is over, if you are hearing it later, if you want to reach out for any queries, my socials are here. So just feel free to ping me. I'll be happy to help in whichever way I can. Thank you so much, guys. It would have been much better if we would have been there in person, but I'm sure we all are embracing this new form of digital transformations and digital sharing of the information. So I'm happy day ahead. There are new interesting talks coming up. So I wish you all the best. And if you need more details or anything from this session, feel free to ping me. Thank you.